In 1984, 1,000 cubic yards of water per second burst out of the ice and thundered into the sea, depositing a layer of sand and gravel 300 feet thick. On this barren plain, hundreds of new streams began carving out new channels to the sea. Fishing is the main industry in Iceland, and the islanders are born seafarers. Although the seas may look calm, sheltered from the North Atlantic gales by tall cliffs and deep bays, the fishing boat crews must be masters of their craft. Many boats have vanished and many lives have been lost in pursuit of this wild harvest. Strong currents below the surface produce dangerous areas of turbulence, which the seals learn to avoid. Beneath these treacherous waters, a forest of kelp sways in water speckled with telltale bubbles issuing from the seabed. At between 70 and 90 degrees, water wells up from an undersea spring. Hot fresh water mixing visibly with the cold salt water in swirling clouds. Mussels line the edge of the spring, attracting predatory starfish. The hot water spring seems to have killed off this mussel colony. In this unstable world, it may have begun flowing quite suddenly, taking them by surprise. Tomorrow, it may well up in another place. Only a fraction of the underwater mysteries of Iceland have been explored by man. The next step is to go deeper off the north coast, where the mid-Atlantic ridge dives once more beneath the sea. The German research vessel Polarstern is preparing to sail from Reykjavik, carrying a deep-sea submersible, a miniature submarine that can dive to 1,500 feet. As they sail, technicians prepare the vessel for what will be its first dive on an underwater hot spring. In 1974, Icelandic scientists found that bubbles were coming to the surface over a place called the Kolbieinsi Ridge. There may be a spring there, but so far, no one has ever seen it. The team uses a mechanical arm to gather water samples and to collect anything else of interest. At 300 feet down, the water temperature is 2 degrees centigrade. Although it's only just above freezing, it supports a wide variety of marine life, much more than the divers expected. There's even coral here. Every square yard of the mid-Atlantic ridge is settled, mostly with filter feeders, exploiting the wealth of plankton. Like creatures from science fiction, the anemones and sponges have grown enormous here. The low water temperature slows down their metabolism and their growth rate, but they live for a very long time. In the still water, some of the sponges evolve into fantastic shapes. Further on, the color of the seabed changes. These brownish, rust-like deposits are the signs of a hot spring that is no longer active. When hydrogen sulfide comes into contact with the oxygen in the water, this is the result. They must be entering the hotspot. Further on, more signs. The white haze on these rocks is a covering of more sulfur bacteria, like those on the land. Outside the little submarine, the water must be full of the poisonous and foul-smelling hydrogen sulfide. But this fish seems not to mind. Perhaps it can't smell. Now the whole landscape turns white, a marbled wonderland, all created by the bacteria. Occasional bubbles reveal that they are on the right track. And finally, the water turns hazy with convection currents, a sure sign that they are near the spring. Water streaming from the spring carries part of the mat of bacteria with it. The temperature outside the submarine has now risen to nearly 20 degrees. The spring is acting like a hot tap, running into a cold bath. There's abundant life around the hot spring, probably feeding on the bacteria from the water. These dense colonies of small white sponges look very much at home here. In the bitter waters of the North Atlantic, they could not survive. But here, they live in tropical temperatures. Like the scientists in their submarine, they inhabit a small world of warmth and safety in a hostile environment. The colonies become more scattered as the submarine draws nearer to the spring itself. And finally, there it is. The water temperature here is now over 60 degrees centigrade, and there is no sign of life on the lava rocks, bleached by the hot current. Inside the chimney, as far down as they can reach with their probe, the temperature is more than 90 degrees, near to boiling point. Now they must try to take a sample of the hot water from within the spring.